Welcome to Data Skeptic. In today's episode, I'm interviewing my longtime collaborator, David Obembe. Most of you listeners have benefited from his work in a number of ways. He's been writing the show notes for several seasons now, and making a bunch of behind-the-scenes contributions to both the podcast and the consulting wing of Data Skeptic. He also recently earned his degree, as you're going to hear about. So I took a look at his thesis and thought, even though it's not animal intelligence, it's super relevant to Data Skeptic listeners. So today we're exploring the uses of large language models for process mining activities. This is where businesses look at their event log data and try and find bottlenecks and other problems like that in their business operations. There's a story, or maybe it's just an urban legend, that some airline took one olive out of a salad where it used to have two and saved, enough money for 2 or 3 salaries annually. I don't like olives anyway. I think it was a smart move. Optimizations like that seem like just the tip of the iceberg. And today we hear how large language models have impacted yet another area of research and industry. In this case, process mining. Well, let's get right into it.
My name is David Obembe. I just completed my master's degree at the University of Tartu in Innovation and Technology Management. I work as the technical product writer in Apromo, and I'm also fortunate to write the show notes here at Data Skeptic and also help in some backend tags in Python.
Oh yeah, you've been a huge contributor actually to the graphs course. Maybe we take a minute and talk about it before we kick off.
Oh, yeah, sure.
Any projects, because you've done a bunch, any stand out in your mind in terms of the contributions you've been making on that effort?
The graph course is going to be an interesting one. I think it's going to be a complete course as though the listeners will be students. We are working on a bunch of projects. I think one of the recent one is the one that involves airport routes, where we load the data set into a network X graph and try to understand what airports are like major hubs. Also trying to see what are the using PageRank and other algorithms to understand exactly how these airports are connected and what are the most frequent routes between flights, and just get a lot of insight from airports.
Yeah, it's a neat data set. And thanks. One of the contributions you made was just making it easy to get that data. You found a good source and showed the import process so people can follow in your footsteps and save a lot of time that way if they want to play with it too.
There are quite a lot. I don't know if this is going to eventually launch with, but we did a bunch of stuff using, trying to create this API with Neptune and Chalice, where we have this API and they're able to query the graph themselves. I don't know if that will eventually launch, but that's also a very interesting project. Getting to work with AWS, Neptune, AWS Chalice, and a lot of database, involved there. Very interesting.
Yeah, a rather complicated project in terms of the number of technologies we were linking, but came together really well.
Yeah.
Let's talk a little bit about your master's program. First off, what is the degree and what does it cover?
So the degree is a Master's of Arts in Innovation and Technology Management. It's actually a very fascinating one because it's a combination of both business administration and computer science. So we are taking courses equally from both faculties, Institute of Business Administration and the Institute of Computer Science. When at the point of doing our master's thesis, we are allowed to either take a supervisor from business administration or from computer science. So it's like a fine balance between management, business management, and IT.
And is it a master's program where you do a project or a thesis? What's the general path?
Yeah, so we are meant to do a couple of courses. It's a 2-year program, so we have 4 semesters. And so the way it is structured, the first 3 semesters will be courseworks, and of course, the courses would have projects as well as an assignment and all that. But eventually, we are expected to do a final year master's thesis. We should take the entire last semester, and yeah, that's how it works at the University of Tartu.
So tell us a little bit about your master's thesis.
Yeah, so my master's thesis is titled a conversational interface for process mining tools using LLMs. And what it aims to accomplish is to understand how LLMs can help enhance the speed of getting insights using process mining tools. Now, conventionally, we know that process mining tools help to convert event logs into process maps, and then business analysts can come on board to navigate through the process map, the charts, the graphs, a number of clicks before they get insights. But with the advancement of LLMs, especially with question answering, we are trying to see how we can make the LLM answer process mining questions. The work served as the background for which we now built a copilot for Aprimo, which was the platform we used, the process mining platform we used.
Well, let's start at step one with process mining. For listeners that aren't familiar with this idea, what is process mining?
So every business has a process, and a process is a set of activity that is done from start to end that create customer value. And so, in the competitive industry, businesses are trying to improve their processes, identify areas of improvement, and just get operational excellence in order to be competitive. And so, process mining is a state-of-the-art technique in business process management that allows organization extract insights from their event logs. So, the beginning of process mining begins with the event logs, which actually is a record of activities done in your process, and a process mining tool takes that event log and convert into a process map, which can then be used to have a good overview of the flow of activities, the traces of activities in your process.
Well, I can imagine a sophisticated technology company where everyone's job is logged into some system and all of the business services they deliver are, updating that system, in which case it's easy to log all the events and what happened in some database somewhere. But if I think of I don't know, running a restaurant, you don't have such a technology luxury. Where do most businesses get their event logs?
So these event logs typically come from ERP systems or CRM systems. They can also come from databases, Oracle, and others. So generally, if a business uses ERP systems or CRM systems, they can go onto these platforms and download the event logs of their process, and then they can pass these event logs on to process mining tools, which can help in performing this analysis.
So I get it in the abstract. You've got a great data set of all the atomic actions in the event log, and you want to describe different processes, I guess repeat processes. But what are the methodologies to take me from raw data to a process?
So that's where process mining tool comes on board, right? Those tools are actually designed to help you convert event logs into process maps. And there are a bunch of things you can do. For instance, you can do process discovery, and that's where you just have a bird's eye view of what's going on in your process from the start event to the end event, all the different traces that can happen. You can also do what they call conformance checking, and that's when you want to understand whether your process is following the expected behavior. So if you have a model, for instance, a set of rules, you can also check, is this process actually doing what I expect it to do? Or are there a few deviations from these rules that I've set? Yeah, so you can also redesign your process. You can understand what the area of bottlenecks are, and then given the insights you get, you can design your process and make it better. You can identify bottlenecks, so you can understand the process, the performance of your process, and know what you can do to make it better. One also important thing you can also do is what we call variant analysis, and that's where you can take two variants of a process and understand what exactly is this process doing, in this variant doing that this other variant is not doing. And then you can know the performance of each of these variants. And then this gives you a good, insight into perhaps what you can take away from this variant and make the other variant better.
Thanks to today's sponsor, Delete Me. I am so glad Delete Me sponsored us because I texted their number too and I like their solution. Delete Me is a subscription service that removes your personal information from hundreds of data brokers. Have you ever wondered how much of your personal data is out there on the internet for anyone to see? It's way more than you think. Too much public information leads to identity theft, phishing scams, harassment, and, as I know very well, unwanted spam calls. But now you can protect your privacy with Delete Me. Delete Me finds and removes any personal information you don't want online and make sure it stays off. Sign up and provide Delete Me with exactly what information you want deleted, and their experts take it from there. They send you regular personalized privacy reports showing what they found, where they found it, and what they removed. That's right, it's not a one-time service. Delete Me is always working for you, constantly monitoring. Take control of your data and keep your private life private by signing up for Delete Me. Now at a special discount for Data Skeptic listeners, get 20% off your Delete Me plan by texting DATA to 64,000. That's text DATA to 64,000. The only way to get that 20% off is to text DATA to 64,000. That's DATA to 64,000. Messaging and data rates may apply. See terms for details. So I'm wondering if we could zoom in on the word process. So I get that also in the abstract, but I can't really picture the data structure. What does it look like, when you're doing a rigorous thing? How do you define a process? Or maybe it's the process map you've mentioned.
Yeah, so a process is a set of activities. An event log records activities that we performed in the organization. So it's really just a set of activities, that is being performed from the start to the end. So for instance, you give an example of the restaurant. Let's say you have a restaurant, a set of activities will be done from when the customer walks in. So, for instance, you take the order, the waiter takes the order, sends it to the cook in the back end. They prepare the meal, they send it back to the customer, they receive payment. So there are a set of activities that are done. And those activities that end up creating value to the customers are really what we call a process. And a process map is a graph that involves what we call nodes and edges. Nodes are activities done, while edges are, they call it directly follows relationship between activities. So for instance, in my example, perhaps the first activity that will be done is to receive the order. And then the next activity that will be done is to send the order to the cook. And so the relationship between the first and second activity is called an edge, or you can also call it an arc. And that's how you build a process map starting from the start to the end.
Well, let's talk about things pre and post LLMs. In the pre LLM world, how did people approach this process of converting event logs to process maps?
It's really process mining tools. There are a bunch of them. Apromo is one. And what these guys do is really just help do that conversion. But after you've converted, that's where the work begins. You need to know how to use these tools. You need to understand what each of these terms is. For instance, if you want to do bottleneck analysis, you know that you have to go to the what average duration or total duration value. You need to perhaps change the level of abstraction. You can either increase the complexity of the process map. And in this case, it shows all the activities and transitions in the process, or you can reduce it. And in this case, it kind of simplifies the process map, picking just the most important activities and transitions, or the most frequent activities and transition. So the bottom line is generally, before LLMs, even as a trained business analyst or process analyst, it takes a bit of effort to get insights from these process maps. And so this project aims to see how we can perhaps use LLMs to make the time to value shorter for the users, by just answering questions rather than navigating through the complex maze of a process map.
So now let's move into the post LLM era. How do you leverage this tool?
Given the possibilities of LLM now answering questions and understanding the world generally as a whole, we can see how we can, pass the information about the process to the LLMs to give us answers. And in this work, we used two different approaches. In the first approach, we got the activity statistics. So for every activity done in the process, we got the statistics in the table, and that would involve the case frequency. So that's the number of time an activity is done in the case, the total frequency, average duration, total duration, information about rework, the average rework, total rework, and all that stuff. Even perhaps the cost of each of these activities. And then we also have a transition table, and this table actually stored the transitions between the performance statistics of transitions in the process. So, for instance, a row will contain a transition from A to B, and the average duration in this case that would be the waiting time, because when there's a transition, the duration is now the waiting time, how long it takes before activity B receives the work done by activity A. And so we have the first table, which is the performance statistics of the activities, and the second table, which is the performance statistics of the transitions in the process. Given this, we're now able to put it into the LLMs using two approaches. The first approach is what we call the direct prompt method. And in this case, we took the entire table into the prompt. And then in the second approach, we took only the schema of the table into the prompt, and we put the tables in a database, an SQL database. And then we told the prompt, rather than answer the questions directly, provide the SQL query given the schema of the tables.
Would you label those activities as prompt engineering?
Basically, I would say the crux of the work was focused on prompt engineering, because so we need to ensure that the answers we're getting, were what we wanted. Perhaps the first few months of the project was iterating and improving the prompt. So perhaps we found out that the LLM didn't understand what a bottleneck is. In the next prompt, we added the definition of a bottleneck. We gave all these explanations until we were sure that the prompt was rich enough for the LLM to start to answer questions.
And what's that process like iteratively? How many rounds do you go through and what do you learn along the way?
One of the things we varied, obviously, was the size of the prompts. So we did like three different prompts: small, medium, large. And then, yeah, in that case, we also noticed that the small and medium gave almost the same result, but the large had a drop in performance. And that would mean that as the prompt get larger, the performance drop. We varied, the LLM we used. So we used two LLMs, GPT-4 and Claude V3 Opus. One of the things we found out again, comparing GPT-4 and Claude was that GPT-4 had, comparing the recall and precision of GPT-4, we found out that the precision was higher. And that means that GPT-4 would rather give you correct answers than incorrect answers. So it's more like a careful LLM, right? It gives you perhaps just as much as you need without boring with so much detail. But while doing that, it misses out of maybe other correct answers. On the other hand, Claude V3 had higher recall and precision. And so it means that, well, it might give you a lot of answers, and perhaps all the correct answers are there, but there could be some noise where you see that perhaps it's returning more than needed, and some of those answers eventually become incorrect.
Well, we got two approaches then. Before you conducted the experiment, did you have an expectation of which approach would outperform the other?
Yeah, so generally, as with everything really in life, it was a trade-off. And for me, I knew that perhaps for smaller processes, so you have shorter tables, tables are not too long, maybe the direct approach would do well because, well, in that case, we know LLMs are good with, when you give them a context and it's to just extract the answers and to do it quite well. In fact, one of the things we played around with while working on this project was to intentionally put the answers in the prompt and ask for the answers. And then in that case, the LLM literally got everything correctly. So when it comes to, well, not too large prompts and putting in the giving the right context and everything it requires to find the answer, perhaps the right approach will work. But yeah, maybe I'm jumping the gun, but there's a trade-off also with scaling. Yeah, where as the prompt get larger, the LLMs may now not pay attention to details and start to make mistakes.
And there's also maybe some challenges with the context window as the tables get bigger and you're going to stuff more into the query to the prompt there.
Yeah, that's correct.
What metrics do you look at to compare performance and decide which approach did a better result?
We technically use two different metrics for the two approaches, and that's because the answers are a little different. So for the first approach, the LMs can return multiple answers. So let's say, for instance, we ask, what are the sources of bottlenecks in this process? There could be more than one bottleneck. It could be maybe an activity has, or two activities has very long waiting time, or an activity has very long processing time. So that this activity is obviously a bottleneck in the process. And so we expect multiple answers. So to capture the completeness and correctness of the answer, we used precision and recall as a metric for the direct approach. So let's say we are expecting five correct answers based on the ground truths. If the LLM returns six answers, of those six answers, the five answers are there. If I'm checking the precision, we checks the correctness. Out of the six answers, five answers are correct. So the precision is 5/6. So it's not entirely correct. But if I'm checking the recall, which is actually the completeness of the model, all five correct answers are there. The answers are complete. And so the recall is 5/5 or 100%. And that's how we, check that both the answer, the LM, gives a complete answer, but a correct answer as well. In terms of the other approach, we are expecting an SQL query. So in this case, we just expect either the query works and it returns a correct answer. So if it doesn't work, that's wrong, or if it doesn't return a correct answer, that's wrong. For the SQL approach, we used accuracy as the performance metric.
And how did the two stack up to each other?
For the direct prompt approach, the precision and recall ranged from about 67% to 87%, while for the accuracy for GPT-4 was 75%, while the one for Claude, I didn't mention we used to LLMs, but yeah, for the one for Claude was 75%.
Do you have a sense of at what point they become useful at an industrial scale, or are you there already?
The work was like the foundation for what eventually went on to become Apromo Copilot. So yeah, this is actually being used in the industry, and many other process mining tools are trying to put in a sort of Copilot in their tool. So yeah, it's actually used, but yeah, most because of the scaling problem with the direct prompt approach. Even though it returned better results, we see that most organizations now use the SQL approach, which is called RAG, and that's where they build an agent that helps to query their database, pass it on to the LM, and there's this round trip between the LM and the database until it returns the final answer.
Do you have any sense of the results you get compared to, like, if you had asked a human analyst to go get the same answer? Is it more a matter of correctness, or are there subtle differences?
Well, first off, humans are prone to making mistakes. LLMs also make mistakes, anyways. In terms of correctness, one cannot say it depends on the skillfulness or the dexterity of the process analyst involved. But one thing that we cannot take away is the time to value. No matter how skillful you are as a process analyst, you have to, engage the tool, you have to click on things, you have to edit things, you have to reduce, the complexity of the models, you have to move to different overlays or, perspectives. So there are a lot of things to play around with before you eventually get your answer. But with LLMs, obviously the time to value is shorter. So it's as easy as asking, what are the bottlenecks in my process? And then it gives you the answers. Or how, okay, given these bottlenecks, how can I improve my process? Or what are the improvement opportunities in my process? And the LLM provides that.
And do you see any other opportunities to take things further in the process mining space?
So what most organizations are doing now is to explore retrieval augmented generation, RAG, really just to build a very powerful agent that can understand the context of the business and give tailor suited answers. One thing also is perhaps not just getting the information about the event log, but to also get documents about the business. So maybe internal document really, and there's a need for privacy there. But yeah, internal document about the business to have a very rich understanding of what the business is about, so that when it's even providing improvement opportunities or it's answering questions, they are not generic. They are based on exactly what the support analyst or the business analyst wants to hear.
So, one thing I know about LLMs is they know programming very well. I don't even give text anymore. I just copy and paste my code and it fixes it or enhances it or whatever. I'm not sure if it knows the ins and outs of process mining, although maybe it read a book on process mining that I didn't read and it knows the techniques for finding the bottlenecks. Do you find that the LLMs sort of get the ideas off the shelf, or do you have to engineer your prompt to teach them a little bit about how to do the work?
I would lean towards the later. These LLMs can just fall back to generic terms when they do not know, the context really. So what we found out again from our prompt was to add all the necessary information it needed about process mining, about things as of today. This field is ever evolving. Just recently, again, they released another version of Claude, another version of GPT-4. So yeah, I think it's ever evolving. But as of the time of working on this project, we needed to actually tell the prompt what exactly we wanted, and so it doesn't fall back to generic terms.
Did you have to deal with prompts hallucinating or being inconsistent?
Yeah, absolutely. And that was actually quite interesting. And we found out that perhaps it was returning answers that were never in the prompt, and it was a little strange. So again, we found all those issues as the prompt got larger, and then it wasn't even paying attention anymore. So yeah, there's also that problem of the LM not returning the same answer given similar prompts. So one of the ways we tackled that was to ensure that for every experiment we did at the same time, both GPT-4 and Claude, we run it at the same time, and we ensure that there was no lag in terms of run this today, conduct this experiment today, and wait 1 week to conduct it next. As a matter of fact, we started conducting experiments earlier last year, but when they released GPT-4, a new turbo version, and then Claude V3, we had to move from we were initially using Claude V2, we had to move to Claude V3 and started the experiment again. So we just wanted to ensure that we had the latest, and then we tried to ensure that we didn't delay in terms of the length of the experiment, because LLMs are ever changing, really.
And what about engineering challenges and putting it all together?
Well, I should mention that we didn't actually conduct we didn't implement the RAG approach. Like I said, it was just a foundational work for further work to be done. We didn't implement, we didn't build the multi-agent, and all that. But we did a few technical stuff like extracting the performance statistics from Apromo, because these performance statistics were not like line following there to write a code to be able to scrape that and get it. So yeah, and that's one of the difference in terms of the project methodology compared to others. Other work we're using what we call this Python library called PM for Pi, and that library helps to abstract event logs into performance statistics and other kind of abstractions. But the performance it abstracts are limited. So for instance, PM for Pi only gets the average duration and the case frequency. But with Apple, we'll be able to get many more performance statistics, including for rework and even costs.
And what's next for you?
Yeah, I'm happy to have graduated. It was a very nice experience. For now, I think I'll just stay into job market and keep on working and gaining more experience. But yeah, the field of process mining is very interesting. I think there's a lot of potential in the field, and yeah, I'm happy to be in the space.
And is there anywhere listeners can follow you online?
Maybe Twitter, or X as we call it now. My name is David with an underscore, so that's DAY_VHEED.
We'll have some links, as you know, in the show notes to listeners to follow up on.
Yeah, thanks.
Well, David, great work. It was a pleasure reading it, and I'm glad we got a chance to talk about it.
Thank you very much. It's a pleasure.